The fluidized bed process. Fluidized bed combustion part 1. The fluidized bed process. The fluidizing process induces an upward flow of a gas through a stacked height of solid particles. At high enough gas velocities, the gas solid's mass exhibits liquid-like properties. Thus, the term fluidized bed. Typical fluidized bed conditions. Figure A shows a container with an air supply plenum at the bottom, an air distributor that promotes even airflow through the bed, and a chamber filled with sand or other granular material. If a small quantity of air flows through the air distributor into the sand, it will pass through the voids of an immobile mass of sand. For low velocities, the air does not exert much force on the sand particles and they remain in place. This condition is called a fixed bed and is shown in figure B. By increasing the airflow rate velocity, the air exerts greater forces on the sand and reduces the contact forces between the sand particles caused by gravity. By increasing the airflow further, the drag forces on the particles will eventually counterbalance the gravitational forces and the sand particles become suspended in the upward stream. The point where the bed starts to behave as a fluid is called the minimum fluidization condition, shown in figure C. The increase in bed volume is insignificant when compared with the non-fluidized case. Request: it is hoped that this session is going to be useful to you. Please press like button. Please सब्सक्राइब दिस चैनल. यह लेक्चर हिंदी में भी उपलब्ध है. As the airflow increases further, the bed becomes less uniform. Bubbles of air start to form and the bed becomes violent. This is called a bubbling fluidized bed. In short, BFB, shown in figure D. The volume occupied by the air/solids mixture increases substantially. There is an obvious bed level and a distinct transition between the bed and the space above. By increasing the airflow further, the bubbles become larger and begin to coalesce, forming larger voids in the bed. The solids are present as interconnected group of high solids concentrations. This condition is called a turbulent fluidized bed. A further increase in airflow causes the particles to blow out of the bed and the container. If the solids are caught, separated from the air, and returned to the bed, they will circulate around a loop defined as a circulating fluidized bed, shown in figure E. Unlike the bubbling bed, the CFB, circulating fluidized bed, has no distinct transition between the dense bed in the bottom of the container and the dilute zone above. The solids concentration gradually decreases between these two zones. Effect of velocity on bed pressure drop. The pressure differential between the top and the bottom of the container changes with airflow as shown in figure. At low airflow, the pressure differential increases with flow through the static bed until reaching the minimum fluidization velocity. At this point, the sand is supported by the air and the pressure differential is determined only by the mass of the bed material. The pressure differential is independent of further increases in airflow until the air velocity becomes high enough to convey material out of the container. Then the pressure differential decreases as mass is lost from the system, which is represented by the entrained flow portion of the curve in figure. Shorter mean diameter, in short SMD, an important parameter for evaluating hydrodynamic and heat transfer performance of particle mixtures, is the sorter, also called volume surface or harmonic mean diameter SMD. The expression for SMD is given. Bubbling bed and circulating bed. Of these fluidization conditions described above, only bubbling and circulating beds are currently used by the power industry to generate steam. Request. It is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। यह लेक्चर हिंदी में भी उपलब्ध है। This lecture is dedicated to the loving memory of my late elder brother Shri Surendra Kumar Chadha.